To find active threats, you want to look for any network activity that shouldn't be happening. As you will already know, we have covered doing this already on the network layer with tools like Wireshark and TCP dump earlier on in the course. But on your actual system, on a Windows system, you can use the tool netstat. That's the main command line tool to examine the network connection. So as you can see there, I've just run netstat, and you can see here we've got the protocol that is displayed. This is TCP. We've got the local connection. So that essentially means it's from this machine, its own machine. And the foreign address is the remote address, the remote location. And the state here, it means that this connection is established. It's an ongoing connection. And we can see here we've got the numbers after this. This is the protocol that's being used. So HTTPS, that means that's port 443. You will see some odd connections and odd high numbers like this, especially on Windows. Windows communicates to itself via TCP/IP ports, and there are other Windowsy services that go on as well. So if you're not familiar with those services, when things like this pop up, then you need to Google or use your favorite search engine to find out what those services are, so you're familiar with the Windows services. So we can add switches to netstat. So the first one you want to be aware of is -A. -A displays all connections and listening ports. So let's try that one. And there you go. So you can see we've actually got a lot more connections there. So we can see here we've got these listening ports. And I was just talking about the Windows services, and that is these. So we can see here on port 135, this machine is listening, and on 445, these are common Windows ports here. So we can see the listening ones, and we can see the established ones where there is an actual connection and data is being sent. Now if we go further down, we can see the UDP connections as well. So that's quite interesting. So obviously we're looking for anything that's unusual, anything that shouldn't be there. Now the thing is, if you're not used to seeing this, you're not going to know what's unusual. But what you should concentrate on is the end point. It is the end location. Where is it actually connecting to? So here, all of these are all internal network names. So they're less of an issue, less to worry about. But when we look at things like this, Stack Overflow, that is an external server. So any external connections, those we want to be concerned about. And another thing we can add to this is O. Now O will display the owning process ID associated with each connection. And that is very important. So for example, if we have decided that this is unusual, we need to follow through on that connection. We need to trace any connections back to the process and process ID that is causing the traffic, and then use tools like Process Explorer, Auto Runs, and Process Monitor, which we've just previously covered, to investigate and remove the persistence that might be associated with that if it is indeed malware. So let's do the -O. And we can see the process IDs here that are associated with it, so we can understand what process it is. Something else you may want to do is add N, which displays the address and port numbers in numeric format. Instead of saying HTTPS, it'll say 443 instead. So if you go there, we can see 443, and we can see the IP address here. And this, for example, is something we can copy, paste into the IP lookup tools to find out where it is. What is it exactly that this system is communicating with? And of course, we've got this process ID 3800, but that's no good really. We want to actually know the name of the process. What actually is that? So in order to do that, we want to add B, but let's remove the N. We do want to display the real names. And let's remove A because we're only interested in established connections. And there we go. So we can see this Stack Overflow, this HTTPS connection, is actually Firefox. So we may be less worried about that now. That may be a website that we are visiting. But if this was some executable that you didn't know particularly what it was, and it was going somewhere that you didn't particularly know where that was, and then you use Process Explorer and you find out it is unsigned, these are suspicious things. So that's netstat. It's pretty versatile. If you do a -H, you can find out all the rest of the switches that you can use with it. But there is a GUI version of this, and that is TCP View, which is another tool from sysinternal, which is essentially a GUI netstat, but it also refreshes, which netstat does not do unless you add some extra tools to it. TCP View refreshes, and it's a continuous monitor of network connections. So of course you can download it from here, and of course as usual you can use Choco to install it, and it's TCP View in order to install it. You want to run it as an administrator, and this is what it looks like. So as I said, it's essentially a GUI version of netstat, and you'll notice that it defaults to just the established connections here. So if we look here, we can click here, we get all of the connections and not just the connected endpoints. And if we go here, we can resolve the addresses or not resolve the addresses. You can see here it's just numeric again, all the addresses resolved. And you've got the same options here. We can change the font size, and we can look at process properties and end process. End the process. We can update the speed and the refresh rate. And we can also do a whois on it as well. And we can see here who owns the endpoint. It's pretty good, nice and quick. And you can copy and paste if you want to use your search engine. So pretty simple, much the same as netstat as we've just gone through. And there's the full list of connections. This is a little bit more useful if you're new, because for example you can see here which ones are the system connections, which you don't need to concern yourself about. And it's easier to monitor active connections due to it refreshing. Another tool you may be interested in is Unhide, which as it describes here is a forensic tool to find processes and TCP/UDP ports hidden by rootkits, Linux kernel modules, and by other hiding techniques. So this is available for Windows and Linux. Here we're using it for Windows. So you can download that, and the syntax for this is winunhide.exe /sys. And it will search for hidden processes and hidden TCP IP connections. If there is anything, then it is a sign of a rootkit. And again, obviously you want to trace unusual connections back to the process that is causing the traffic, and then use the tools, Process Explorer auto runs, Process Monitor to investigate and remove persistence as needed. As I mentioned, you want to use tools like domain tools in order to put the IP address in of the remote connections that you find, to try to discover what it is they are in order to eliminate them if they are in fact genuine.